Hello, everyone. We're working on Chapter 14, Part 1 of an Introduction to Statistical Methods and Data Analysis by Ott and Longnecker, ANOVA for completely randomized designs. So we're going to do an example where we're going to compare package designs of products, and the outcome is the mean ratings. So in this design, we have 4 different package designs that we're considering. One, 2, 3, and 4. And what I've done here is I've started to put this into a data set in R, where we have the design, which is essentially the treatment. The store are the particular observations. YIJ, that's the rating of the product. For the jth store for design I. So just as a quick note, the design of the package is the treatment. So I equals 4, and the experimental units are the actual stores. And N1 equals 2, N2 equals 3, N3 equals 3, and N4 equals 2. So first we could calculate the Y bar I dots. And in R, you can use the tapply function, where you tell the computer what your response is. That's our YIJ. And then the index is what you want the means of. So if I want the mean for each of those designs, my index is design. So here, these Y bar I dots are found in the code here. Okay, the S squareds you can find by using the same function of tapply for the ratings. We're still indexing by the design, but now we're asking for the variance. So this is the sample variances given by 18, 1, 4, and 18. Okay, we can calculate the overall mean Y bar dot dot by just taking the mean of all of the YIJs. So we get a Y bar dot dot of 18. All right. If we wanted to, we could start filling in this ANOVA table. So in this case, we have that, right, T equals 4. So the degrees of freedom for the treatment is then 3. And the degrees of freedom for the error, well, N is the total number of observations. We have 10 observations, so this should be 9. And then we have N minus T. So 10 minus 4, which is 6. So those add up so far, and that's looking pretty good. Now, if I wanted to, I could do all the calculations by hand that we showed the formulas for, or I could fit a linear model in R using the LM function. We're going to have our response follows our factor of design. Now, the reason I put factor design here is because this is a categorical variable. So we have 4 different groups. So I designated that using the factor command. If I get the summary of fit CR, that's going to give me the coefficients as well as the overall F test in this final line. So here, I know that my F statistic is 11.22 and the p-value is 0.0071. All right, now I just need to get the sum of squares and the mean squares. So what I do is I take an ANOVA of the fit, and I can get the sum of squares due to design, or due to the treatment being 258. The sum of squares error is 46, right? The sum of squared total, that just adds those up. So 14, 10, 304. The mean square here is 86, and the mean square error is 7.667. So that 11.22, right, is just that 86 divided by 7.667. So if I draw my curve, if I'm testing if there's a significant difference in the treatments, right, I can set up my rejection region. If I set that to be alpha is 0.05, the F critical value is 4.76. And that is putting 0.05 area in the tail. So essentially here, anytime I see an F value bigger than 4.76, then I'm going to conclude that at least one of the treatments is significantly different than the rest in terms of mean ratings. So here, when I do this, I get a value for my test statistic of 11.22, so way up here, okay? So this p-value right here, the error is very small, 0.0071, and this is my test statistic of 11.22. Now, overall, when I see this, I could have just looked at those original means and said, okay, I see mean ratings 15, 13, 19, 27. Just eyeballing that, it looks like group 4 has much higher ratings than the rest. So that package design is probably much higher for group 4. The difference between 15 and 13 most likely isn't practically significant. Whether or not it's statistically significant is a different story, but overall, when I see these treatment means, I see that I am looking at the package design possibly influencing the rating of the product. And when we carry out our statistical test, we saw the same thing. So I hope you learned something today, and I'll see you in the next video.